Hello everyone. Welcome to the solution of LeetCode problem 88 named Merge Sorted Array. In this problem, we are given two integer array, which is num1 and num2, and both of them are presented in non-decreasing order. And we are given two integers, which is m and n, which represents the number of elements in num1 and num2 respectively. Now, we have to merge this both of the array into a single array which is sorted in non-decreasing order. Suppose in the first example, the first input array consists of 6 elements, which is 1, 2, 3, 0, 0, and 0. But there are only 3 non-zero elements, which is 1, 2, and 3. In the second array, which has 3 elements, which is 2, 5, and 6, and it has 3 non-zero elements, which is 2, 5, and 6. So we have to accumulate these 2, 5, and 6 with this 1, 2, 3 and add them in a single array and make the array non-decreasing or increasing. So if I add 1, 2, 3 and 2, 5, 6, the array will be 1, 2, 2, 3, 5, 6, which is a non-decreasing or increasing array. So here the array are merging, which is 1, 2, 3 and 2, 5, 6. So the final result will be 1, 2, 2, 3, 5, 6. Here, this 1, 2 and this 3 is the elements of first array. I hope you understood the problem. Now let's move on to the constraint here. The first array length is equal to the m plus n, and second array length will be equal to the n, and both of the n and m is in between 0 to 200, and the summation of m plus n in between 1 to 200, and each element presented in both of the array can be in between minus 10 to the power 9 to positive 10 to the power 9. Here, the follow-up question is, can we solve this problem by using big O of m plus n time complexity? Yes, we will gonna solve it with this time complexity. I hope you understood the constraint and the follow-up questions. Now let's move on to the algorithm. To solve this problem, we're gonna use the 2 pointers algorithm. Here, we are using 3 pointers. The pointer I is pointing to the last non-zero element of the first array. Pointer J is pointing to the last element of the second array. And pointer K is pointing to the last element of the first array. And we will put the corresponding element at the kth index. Now, the problem is we have to insert this entire second array to the first array. And we have to use the 2 pointers algorithm. Now here, we are checking the value presented at ith index and the jth index. Now, the value presented at ith index is 3 and the value presented at jth index is 6. And between these two, 6 is greater. So we have to insert 6 here. And we have to update our current pointer value k. Now k is pointing to this element. And as we put 6 here from the second array, we have to also update our current j. So our j is pointing to this 5. And our I is still pointing to this 3. Now, the value of I is 3 and the value of j is 5. So between 3 and 5, 5 is greater. So we have to put 5 here. And we have to upgrade our pointer from this element to this element. Now, we have to again update our pointer of j from this element to this element. Now, the value presented at ith index is 3 and the value presented at jth index is 2, and between these two, 3 is greater. So we have to put 3 here. Now, the value presented at the ith index is 2 and the value presented at jth index is 2. So between these two, both of them are equal. So we have to put 2 here instead of 3. Now suppose these 2 comes from this last array. Now we have to upgrade our pointer j and we have to upgrade our pointer k. Now k is pointing here, but we have to notice that our current j pointers became out of bound. That means we have inserted all of the array element of b into the first array. Now, the final output of the first array is 1, 2, 2, 3, 5, and 6. And we have seen that this array contains all of the elements from the first and the second array, and which is also an increasing order. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named merge, and it has 4 parameters: the first array and the value of m, the second array and the value of n. Now, here we have to check whether our current j pointer is inbound or greater than is equal to 0 or not. If it is, then we have to check whether our current I is inbound, and if our value presented at ith index is greater than the value presented at the jth index. If it is, that means we have to assign the greater element, which is a of I, to the a of k, and decrease the value of I and k. Otherwise, we have to assign b of j to the a of k, and similarly, we have to decrease the value of j and k accordingly. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n plus m, where n plus m is the summation of the two arrays. And the space complexity is big O of 1 because we are using only constant extra spaces. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.